And this is in your notes. There's the steps to solve these that are really similar to when we did absolute value equations. You always isolate what's ever inside that absolute value expression first, so it's the only thing on one side of the absolute value. And then you create two cases, one where the expression is not negative, one where it is negative. You solve both of those inequalities, and then finally we're going to graph them. So there are two different kind of scenarios. One where the inequality is less than, and we're going to go through some examples of those first. This is in your notes, but I want to go over it and make sure you're really clear about what this is saying. So here, this is saying the absolute value of x is less than 3. What this means is that the distance between x and 0 is going to be less than 3. So if this is 0, maybe it's just 1 away from 0, 2 away from 0. But it can be anywhere in this distance. This is 3 units. This is 3 units. So anywhere in this area is the solution for x. So let's go over some examples of what this might look like. So here, if we have the absolute value of x is less than 7, what you want to do is create those two cases. Now, case number 1, you're just taking what's in that absolute value symbol. The inequality stays the same as less than, and then I just say 7 because it's not negative, it's positive. For the second one, there's two things you need to do. This stays the same, but you want to switch that symbol. So it's not less than anymore, it is negative. It is greater than. And then instead of 7, it is negative 7. So this is my solution. The last step is to graph it. And when we do that, I'm just going to put some of the key numbers like 0, 7, negative 7. I'm not going to put all my other little tick marks and label them in here. But what this first one is saying is x is less than 7. So it's not equal to 7, so I'm going to do an open dot there. But it's everything less than 7. And then this one on the right is saying x is greater than negative 7. So it's not equal to negative 7, but it's everything greater. So this is one of those and compound inequalities. If it's greater than negative 7 and less than 7, it's somewhere in this space. Okay? So take a moment and make sure you have all of this down. If the teacher needs to pause the recording, they can. So let's go over another example here. So first off, you want to make sure whatever's in the absolute value is all by itself, and it is, meaning there's nothing over on this side besides the absolute value of x plus 2. So since it is, I'm going to divide it into my two cases. The first one again, I just take what's in the absolute value. I leave the symbol the same. The inequality symbol is still less than or equal to, and it's 7. It's not negative, it's just 7. The second one, what's inside the absolute value stays the same, but instead of less than or equal to, I'm going to say greater than or equal to. So I'm going to switch that. And instead of 7, I'm going to say negative 7. So those are the two key points again. You're switching that sign. Instead of less than, it's now greater than. And instead of 7, it's negative 7. So for these, now that I've set up my two cases, I can solve them. So I want to solve for x. So you just go through each one individually. I undo adding 2 by subtracting 2. Since I just subtracted, I don't change that symbol. This is just the answer there. And then on the one on the right, and again, in order to undo adding 2, I subtract 2. Again, subtracting 2, you don't change your symbol. It's still greater than or equal to. But negative 7 minus 2 is negative 9. So after you've solved all this, that's when you graph it. So I'm just going to, again, just draw some of the key points here. 0, and here's the -9 approximately, and here's the 5. And if you look at each one individually, x is less than or equal to -5. So it's equal to -5. Is that an open dot or a closed dot? It's a closed dot. And it is less than that. So we're going to go this way. And then the other one is saying x is greater than or equal to -9. So again, if it's equal to it, we do a solid dot. And then it's greater than. So it's everything between these 2 points. So again, it's one of those and compound inequalities, so we can just change that to a solid line. So again, if the teacher needs to pause so everyone can write this down, you can do that and press play when you're done. We're going to go over one more example with these less than absolute value inequalities. So again, you want to make sure the absolute value is by itself, and it is. It just has that absolute value over here, nothing else. So at that point, we can divide it into 2 inequalities. So again, the first case is easy. It stays exactly the same. It's still less than, and it's just +10. The second one, though, think about it. What are we doing different for this? It's still 2x plus 4, but what changes now? Instead of less than, it's going to be greater than. And instead of 10, it's going to be -10. So now that I've set these 2 up, that's when you start to solve these 2-step inequalities. You want to move things away from the x, away from that variable. You always undo, let's undo that +4. And you can do that by subtracting 4 from both sides. I just subtracted so the inequality symbol stays the same. It's still, it's still less than, but 10 minus 4 is 6. It's almost by itself now, but I need to undo the multiplying by 2, and I do that by dividing by 2. And I just divided by a positive number, so I don't change the symbol, so it's still less than, and 6 divided by 2 is 3. So we're going to go through the same process. It'll just be a slightly different answer on the right. We undo the +4 by subtracting 4. The symbol stays the same, but -10 minus 4 is -14. And then again, to undo multiplying by 2, I'm going to divide by 2. I just divided by a positive number, so the sign stays the same, so that's -14 divided by 2 is -7. And now this is our solution. The last thing we need to do is just graph that. So I'm going to just draw a little makeshift number line here. Put some of my key points, my 0. Maybe this is -7. About here is 3. And you just take them one at a time. So x is less than 3. It's not equal to 3, so do we do a solid dot or an open dot? You do an open dot, and it's everything less than. This is the L. It means less than. We're going to go this way. Remember, the head of the arrow kind of looks like that less than symbol. And then the other one, x is greater than -7. It's not equal to -7, so you want to do that open dot. But it's everything greater, everything bigger. Numbers get bigger as you move to the right. And again, this greater than symbol kind of looks like the arrow going to the right. So it's everything between -7 and 3. So again, you just make this look like one of those compound inequalities you guys graphed. And that's the answer. All right, so let's go over the greater than inequalities, the absolute value inequalities with the greater than symbol. So these are slightly different. These are somewhat like those or compound inequalities. What this is saying is the distance between 0 and x is greater than 3. So it could be greater than 3 going to the right. So if this is 0, it's not in here. It's not 1 away or 2 away. It's over here. It's 3, 4, 5, 6 away from 0. And the same for the left side. It's -3, -4, -5 away from 0, and so on. So let's go over some examples of those. So with this, we're following the same process. The first one stays the same. So this one is just, it's x greater than symbol, and then it's just +4, non-negative. And the one on the right is x less than symbol, -4. So again, the difference is that you change the symbol from greater than to less than, and then the other difference is it was +4 and now it's -4. So you take that on your number line and we're going to graph it. So let's put -4 and 4 here, some of our key points, and you graph each one. So the first one says x is greater than 4. So it's not equal to 4. So I'm going to do an open dot, and then greater than goes to the right. The second one here says x is less than -4. So it's not equal to -4, but it's everything smaller than -4. So it goes to the left. Okay? So these look like those compound inequalities with the or. It's either greater than or it's less than 4 or -4. All right, let's look at this one here. So this one, if I'd like the teacher to pause the recording, and I want you guys to try this one on your own, and then the teacher can press play when you're ready, and you can check your answers and see if we got the same thing. All right, this is what I got. A couple of key things in case yours looks different. I had my x -1, and the symbol stayed the same as greater than, and I kept this as +6, and then I solved it by adding 1. The one on the right, though, I changed the symbol. This one is now less than, and I changed it to -6. And I, again, just added 1 to solve it. These two, again, if it's greater than 7 or equal to, it's a solid dot and it's going to the right. If it's less than -5 or equal to, it's a solid dot and it's going to the left. Let's try one more. So this is the last one. Again, why don't you guys have the teacher press pause? You try this one on your own and then press play when you're done and see if we got the same answer. All right, here's what I got. Oh, shoot, it went away. Hold on. All right, here I go. So take a look and compare your answer to mine. This is not hilarious. Hold on. All right, guys. So a couple of things I wanted to point out is the first one is still 2x plus 5. And I am keeping the symbol the same, and it's equal to +3. And then I subtracted the 5 and divided by 2 to solve it, just like you do for two-step equations. The second one, though, instead of greater than, I changed the sign to less than, And instead of 3, it's now -3. And then again, subtracted the 5 and divided by 2 like you solve a two-step equation. When you solve these, it's not equal to -1, so that's why I did an open dot. It's not equal to -4, open dot. And then again, greater than's to the right, less than is to the left. So now I'm going to make this one disappear. And I just want to show you what the practice is. So the practice is in the textbook. The link is in the classroom, or you can borrow one of the books over on the bookshelf, or the teacher can pause this recording. I just pasted the questions on here. After I printed the notes, I thought, oh, I should have pasted the questions on the notes. So I apologize, they're not on the hard copy, but they are on the Google Doc copy that is in the classroom. So here you go. Please give these your best shot, and I will hopefully see you guys tomorrow.